Hello, my name is Ayanle Hashi, and my semester project is on using classifiers to determine whether or not a star has exoplanets. An exoplanet is a planet that orbits around a star that isn't our sun, and astronomers are searching the night sky for them to find signs of life or potentially habitable planets that humanity may migrate to in the far future. There are many different methods used to detect these star systems, but the one I focused on for my project is called transit photometry. Basically, when an exoplanet passes between us and its star, it's the measured brightness or flux of the star dips ever so slightly from our perspective, as indicated by the red line on this diagram. By analyzing the pattern of these dips, we can determine whether or not there is an exoplanet orbiting it. The dataset I used contains flux versus time values for over 5,000 stars, with each row having over 3,000 consecutive flux measurements. Each star was classified as either having exoplanets or not having them. The core of my project involved comparing three classifiers to determine which performs best on this type of data: a Gaussian naive Bayes classifier, a decision tree, and a linear support vector machine. In my literature review, I found that a majority of the scholarly papers implemented a neural network or similar variants to solve this problem, so I chose a multilayer perceptron as the baseline method to compare the three classifiers with. I evaluated my results using the F1 score, as it is best suited for binary classification problems. The results of my experiment are listed here. Out of all the classifiers I compared, I found that the decision tree was the only one that had a score close to that of the perceptron, with the SVM performing decently well and the Gaussian naive Bayes classifier falling far behind. The reason for this large difference is most likely because the naive Bayes algorithm assumes that the data follows a normal distribution, but the light curve data I used for my experiment was shaped more like a sine wave, and so it does not work well with this method. If I were to repeat the experiment in the future, I would find a more balanced data set and compare more classifiers other than the three I used here. Overall, I would consider this experiment as a success, as it reflects the findings of other scholarly papers on the subject.